In this video, we will be seeing the merge intervals problem and find a solution using JavaScript sorting method, and we will be also computing the time complexity and space complexity of the solution that we are going to be building. Before jumping into the solution aspect of it, let us first try to understand what the problem statement is. We are given an input of an array which is going to have intervals, and these intervals are going to have a start and an end. So this is the start, this is the end of interval. Similarly, this is the start and this is the end. From this input, there are going to be some intervals that are going to be overlapping. For example, if you take 1, 3 and 2, 6 on a scale of 1, 2, 3, 4, 5, 6, if I just represent this 1, 3, it goes from here to here. If I represent 2, 6, it goes from here to here. As you can see, this part is overlapping between the two intervals that you are given. What we are supposed to do is we are going to be merging these intervals to remove the overlap and combine them into one. So it will be 1, 2, 6, and then in the end we are going to return our output, which is going to be array of this non-overlapping intervals that are left with us. So we will have some overlapping intervals, some non-overlapping intervals, and what we are going to do is whatever is overlapping, merge them, and whatever is non-overlapping, just put them in a result array that we are going to be returning. So this is the problem statement, and we said that we will be solving this using sorting. What we are going to do at first is that whatever input we receive, we are going to get that sorted first. So this is going to get sorted based on the start of the interval that we have. So in each interval, whatever start you have, we are going to sort ascending order of this start of the intervals that we receive. So first step is we'll be sorting. After we sort, what we are going to do is we are going to pick one of the intervals. Let's say we pick A. We will check that the end of A. So when we say A, let's say 1, 3, and we pick B, which is 2, 6. What we will do is we will pick A's end, which is 3, and we will say, hey, is this 3 that you have in this sorted list of yours based on the start element, the start of my B. So we will be picking B's start, which is 2, and we will say, hey, is the end greater than or equal to the start of my next interval that I have. So this is my current interval and this is my next interval, and I will check the end of my current interval is greater than or equal to end this part, which is coming from here, and the start, which is this part, which is coming from here. We will compare these two. If the end is greater than the start, that means they are overlapping and we need to merge these two intervals. So what we will do is we will keep the start constant as it is from our current. So from the current we pick up the start, and the end is going to be the max from the ends of the elements that you have received. So we have received current as this one, next as this one. We are going to pick the max from both these ends that you have. So from 3, 6, whatever is max is going to get picked. From 3, 6, the max value is 6, and we are left with 1, 6 that you have here. So it's going to be 1, 6, which is going to be the merged non-overlapping interval. So from two intervals, we created one interval, and this is what is going to go in my result array that we have. So that's basically the logic part around it. And for this to work, we have to make sure that the array is sorted, because if it is not sorted, then this check that we are doing will not work as expected. And that's pretty much it. What we can do now is jump into the solution aspect of it from whatever we had covered so far. So let's say you have a result array that you want to return. So what we'll just do is in the end return whatever you have in your result. The critical part, that is what I mentioned, that we will be sorting this array that you receive, and the sorting is going to be happening on the start of the interval that you have. So we will say a of 0 minus b of 0. This is basically going to be using a compare function, and the start of a and start of b are going to be compared, and if start of a is lesser, this returns a negative value, which will mean that a will be placed before b in the sequence in the sorted array that you have. After we sort, what we are going to be doing is pick up my current element, that is the current interval that I'm looking at, and my next element, which is going to be my next interval, and then compare this way like we did here. And to do that, what we will do is say current interval is going to be my intervals of 0. So I just pick the first element from the sorted list that I have, and then result dot push this current interval that I have. So I just push it in my array, and then in place I will be modifying by using reference. So first I sorted, then I took my current element, then I'm going to do something like this. Let interval of intervals, I'm going to iterate through my intervals array that I have, and from this current interval that we have received here, what I will say is pick up the current start and the current end that you have from your current interval. Then because we are going to be iterating from these intervals, so from this interval also I will pick up whatever next I want to be considering here. We consider two parts. First is the current that we want to pick, and then we have the next element. So the next part is going to be next start and next end. So we picked up A and B. Then we said we will be comparing the current end, which in this case was 3, and the next start. And if the current end is greater than equal to my next start, then that means we have an overlap and we have to merge them. And how the merging happens is something like this. We will just say current interval of 1 is going to be math.max of my current end that I have and my next end that I have, whatever max I'm going to get. And this happens in reference updation. So we first put this current interval into our result, then we took reference from current interval here, and then directly current interval of the end part we are directly changing here. Otherwise, we said that the input array can consist of overlapping intervals and non-overlapping intervals also. If it is non-overlapping, then what we have to do is just simply push it in my array, and then I can start from that as my current interval, assuming that the next one might also be overlapping with my current. So in that case, what we can say is my current interval becomes my interval that I'm dealing with, and then I can just do result.push my current interval, whatever current interval I have after updating. And that's pretty much it in terms of logic. In terms of the time complexity that is going to be involved here, we are doing sorting here, which is the most heavy operation involved here, and time complexity of sorting is going to be n log of n. And then we just use this initialization big O of 1, we can just discard it. We are going through a loop here, which is going to be big O of n. So in the end, we are going to be something like big O of n log of n plus big O of n, which in turn becomes the overall time complexity of n log of n, because this in comparison to this is smaller. So this is very huge. So we just pick the huge one because then this just becomes negligible in the presence of this. And in terms of space complexity, what we will say is we are sorting, we are just using this in place updations. So in terms of space, we are not using a lot of space here. But when we are doing this sorting happens linearly. We are just using the comparator and we are sorting in place linearly. And because of that, space is going to be used. And that leads to big O of log of n in terms of space complexity. Only this sorting part. This in place in terms of using space complexity will be big O of 1, which is constant, which is quite negligible compared to this. So hence the overall space complexity is big O of log of n. And that's it. Thank you for watching. Please like and subscribe.